Imagine this. You are plummeting toward Earth at exactly 17,500 miles per hour. Just inches outside your window, the atmosphere is violently ripping apart, generating a blinding plasma field that burns at 3,000 degrees Fahrenheit. If a single heat tile fails, you evaporate in less than a second. For decades, surviving this fiery plunge required a very specific, undisputed set of engineering rules. But SpaceX didn't just bend those rules with the Crew Dragon, they completely shattered them. Legacy aerospace engineers actually called this spacecraft a death trap when the designs first leaked. Why? Because SpaceX stripped out the physical controls, strapped a bomb essentially to the astronauts' backs, and built a system that relies on a terrifying 100 millisecond reaction time to keep the crew alive. How is this even legal? Stay with me here, because what you're about to see changes everything. To understand why the Crew Dragon is considered an impossible machine, we have to look at the normal way humans fly in space. Historically, like with the Apollo missions or the Russian Soyuz, spacecraft were flown with hundreds of analog dials, physical switches, and disposable escape towers bolted to the top of the rocket. They were brilliant, but incredibly heavy, expensive, and wasteful. But this is where things get strange. Elon Musk's team decided to build a spaceship that looked less like a 1960s submarine, and more like a glowing, autonomous alien artifact. What I'm about to reveal next is the classified level engineering that allows this ship to practically fly itself, and it's exactly why so many people are joining our Deep Space Secrets community every single day. If you want to uncover the hidden truths of the cosmos with us, hit that follow button right now. Because the deeper we go into Dragon's systems, the crazier it gets. Let's rewind to April 2019. The Crew Dragon program is in the final stages of testing. But during a routine engine check at Cape Canaveral, boom. An anomaly occurs, and a test capsule is completely obliterated in a massive toxic fireball. The world watched in horror. Legacy spaceflight experts whispered that SpaceX's radical design was flawed. The detectives at NASA and SpaceX scoured through the twisted metal and telemetry data. What they found was a leaking titanium valve that caused highly reactive oxidizer to ignite under intense pressure. But instead of scrapping the ship, they redesigned the entire plumbing system in record time. But the fix led to an even bigger mystery. How do you safely launch humans on a rocket that you know could theoretically explode? The answer is the Super Draco engines. Instead of a disposable escape tower, SpaceX 3D printed 8 hypergolic thrusters and built them directly into the walls of the capsule. If the Falcon 9 rocket starts to fail, the Dragon's onboard computers detect the anomaly and ignite these engines in exactly 100 milliseconds. That is faster than the blink of a human eye. It generates 33,000 pounds of thrust, ripping the astronauts a mile away from the explosion in under 5 seconds. It's the ultimate ejection seat. But that's not the most controversial part. But here's where it gets crazy. Just when you thought you understood the hardware, let's talk about the software. There are no joysticks in the Crew Dragon. The astronauts fly this 26,000-pound machine using touchscreens. And the interface? It's powered by modified C++ and Chromium. Meaning the software keeping these astronauts alive is built on the same underlying code as your Google Chrome web browser. Veteran astronauts were initially terrified. What happens if the screen glitches? What if you hit a dead zone in space? This sparked a massive debate in the space community that is still raging today. I genuinely want to know what you think about this. If you were sitting on top of 1 million pounds of explosive rocket fuel, would you trust an AI-driven touchscreen to save your life? Or would you demand physical, analog switches like the old Russian Soyuz? Drop your wildest theories and opinions in the comments below, because I'm reading every single one. Would you fly in this thing? By the end of this video, you'll understand why this debate actually dictates the future of human survival. Aerospace engineers around the world are now realizing that Crew Dragon isn't just a taxi to the International Space Station. It is the proving ground for something much bigger. This software, This autonomous docking system that lines up spacecraft within a millimeter of accuracy in pitch-black darkness, it's the exact same architecture we will need to land humans on Mars. If we can't trust autonomous AI to dock a ship in low Earth orbit, we have zero chance of surviving a 300 million-mile journey to the Red Planet. This affects how we see our place in the universe. Despite the exploding test capsules and the fierce skepticism from the old guard, the Crew Dragon has become the safest, most reliable spacecraft in human history. It has restored America's ability to launch its own astronauts and has opened the door for private citizens to finally touch the stars. Think about the Polaris Dawn mission, where everyday people are stepping out of the Dragon's hatch into the vacuum of space, protected only by a SpaceX suit. We are looking at a future where accessing space is no longer restricted to government billionaires, but is becoming as routine as commercial air travel. Science is progressing at a blinding speed, and every successful splashdown proves that when we challenge the impossible, we usually win. But the Crew Dragon isn't the only spacecraft making headlines for breaking the rules. Wait until you see the classified engineering behind SpaceX's colossal Starship, or the shocking reasons why Boeing's Starliner has been facing mysterious anomalies in orbit. We are breaking down those impossible files next. Thank you for uncovering another piece of the cosmic puzzle with us today. The engineering of the Crew Dragon proves that magic is just science we don't fully understand yet. The universe is full of secrets, and we're just getting started. Stay curious, keep looking up, and I'll see you in the next video.